Hi, everyone. This is Rob Gray from ASU and the Perception Action Podcast, back with another article review. In today's episode, I want to touch on a topic I've talked about a lot on the podcast. It's been in my big bugaboos or big issues on this is the potential benefits of generalized perceptual cognitive training for sports performance. So I'm talking about things like doing training by watching little dots move around on a computer screen, or watching flashing lights on a board, or using a bead on a string, right? So using generalized, out of context, non-sport specific stimuli, the idea that they can transfer to better performance on the field. If you followed the podcast at all, you know I'm not a believer at all in this kind of approach. I'm talking about things like S2 cognition, uh, NeuroTracker, the Nike Spark system. All of these purport to train things like general visual functions like attention or processing speed or inhibition out of context, and with the idea that it's going to make you better and transfer on the field. In my opinion, that there's no evidence to support that, and everything I understand about how skill works, it wouldn't expect it to improve that. Um, that's just my opinion, but I think there's a lot of evidence to back it up. I think could be some diagnostic value in some of these tests, right, for showing deficits, but I don't think there's any training benefit. And as I said, the research seems to back me up on this. It's something I've thought about for a long time. What is my problem with some of these tests, right? There's multiple problems. Training. So imagine training. Let's talk NeuroTracker, which is what we're going to talk about today. NeuroTracker is watching yellow balls move around the screen and keeping track of three of them. What's called a multiple object tracking task, and it's supposed to make you a better basketball player, like being able to track what the defense is doing. The problems I have with this: one, perception action decoupling. You're training perception separately from the action is which it's coupled to, right? So in these tasks, the response is pressing a button or hitting a light on a screen, not not doing a multiple degree of freedom coordinated movement like passing a ball or dribbling pie. So it goes against that. More importantly, there's no information in these kind of stimuli. Dots moving around the screen is not the same as gaps opening and closing between defenders, tau, direction of movement, all of which specify affordances, which is my next point. Right? They specify opportunities for action directly. And all of this is missing from these generalized displays. My last point is most of them have unrepresentative task constraints, in particular time constraints. And most sports skills, you have a fraction of a second to take in visual information and use it to control your action, make decisions. In these tasks, you have seconds, like 1 or 2 seconds to do it. So I don't think it's very representative. And if you just think about the face validity, so if you think about three tasks: Dynavision, which is where you stand in front of a big board and you hit lights in your peripheral vision to turn them off; NeuroTracker, multiple object tracking; and even Madden football, which some people said help you learn to play football. Think about the face validity, right? So with Dynavision, where you're turning off the little lights, we're teaching you to respond as quickly as possible to the first thing you see in peripheral vision and immediately react to it. Is that really, if we're talking about training for football, American football, is that really what you want your quarterback to do? As soon as they detect something in their peripheral vision, to get rid of the ball? No, right? They want to pick up information about how fast they're approaching, how much time do I have, what direction are they coming, so on. In With NeuroTracker, these yellow balls moving on the screen, the motion is completely random. It lacks the information you get from the game, right? The opening and closing of gaps, tau, all the information that tells you what actions are afforded, right? That specifies. And then most of this, as I mentioned, in Madden, right? There's no multiple degrees of freedom to perform a spin move like you do in football. There's the B button that does it all for you. So all of these things are lacking. As I said, I've been very skeptical of it. This is all my opinion, right? These and don't come after me, these companies. These are my opinions backed by the evidence. There's no evidence that training on these things will make you better on the field, right? It goes against everything I understand about skill. And as I said, there's no evidence. The one piece of evidence that seemed to be in support of this is this study. Right. So this study by Romeus and colleagues, by the last author, Jocelyn Faubert, is the inventor of NeuroTracker. He is a very eminent professor at University of Montreal who studied neuroscience for a long time. Great researcher. I'm going to talk a little bit more about that. I reviewed this paper in episode way back in episode 21C. And myself and many others have been very critical of this study. It's the only one that really demonstrates transfer to improve sports performance. So in this study, they had people perform the neural tracker test, which is multiple object tracking, following the yellow balls on the screen, and they showed it makes you make better decisions in a passing test on the field. The problems with this study were the lack of a proper control group, not enough subjects, and most problematically, the way that decision making was assessed on the field was by one rater who knew what condition people were in and was one of the authors of the paper, if I remember correctly, or is heavily involved in some way. Right. So very, very potential for bias in the judgment. And as I said, I'm not the only person to critique this. At this point, I want to take a little aside and I want to confess to something. So sometimes when I talk about things like this and I get a little grumpy. People have noted that when I critique the constraints led, the putting more texture on the constraints led approach paper, and other times I get a little grumpy. And I did with this, but so several years ago, I was at a conference talking about visual training, and I presented on this work, and I was very, very critical of this paper. In my presentation, I was kind of joking around. I said, if I had reviewed it, it would have got rejected, which that's not a lie, right? They had some major flaws. I don't know how they got by those kind of flaws. So I don't think my criticisms were so much problematic. It was my tone, right? I was a bit too aggressive and a bit too cavalier about it. And one of the authors was in the audience, and it kind of bothered them, and they contacted me afterwards, and we kind of reconciled. But again, I want to apologize for if they're listening. That I have to be careful sometimes. My passion for this stuff kind of takes over, and I lose my Canadian politeness, and I get a bit too aggressive. Right? This is science. We should be professional about it, not be so aggressive about it. But anyway, so that's the background for this. What I really want to compliment the authors a few times here, not just because I feel bad, but because one of the things I really respect Justin Faubert for, and these co-authors for, is most sports training technologies, they develop something, put up a website, and they never provide any evidence whether it works or not. Right? They have a science page that says points to a bunch of irrelevant articles on neuroplasticity, but they never actually take the time to show their test improves you on the field. They talk about 1% gains and all these things. These authors do, right? They take the time to actually evaluate and test their product. So I give them a lot of kudos for that. And in that regard, one of the things they did, they took these comments by myself and others, I don't know if it's specifically me, but other people have raised about this study, and they tried to replicate it, sort of. Right? They're not going to do the exact same thing. They want to see if they can get the similar effects. There's going to be some big changes to the study and big improvements. They want to see whether they can get those same effects of far transfer from improved training on neural tracker on the computer screen to improved soccer performance on the field. Right? That's what they want to try to demonstrate. And you can probably see from the title, they failed to do that. But I give them, again, big kudos. For one, they could have not bothered to do this study and just stuck with the first one. Two, they could have run this study and filed the results in their drawer, because most of the results are not significant, which people would have done in the past. So again, a lot of credit to the authors for following through with this and trying to improve the quality of their evidence and actually investigate it, which, as I said, most companies would never do. So let's talk about the study. So this study is a follow-up to that earlier paper. They're going to take on the critiques of a lot of other studies. They're going to have a bigger sample size based on a power analysis. They're going to have a proper control group. They're going to add a test of near transfer, right? So they're going to add another computer-based cognitive test to see if neurotracker training improves you on that, and far transfer, which involves two blinded raters that are not part of the study team. So lots of improvements. Kudos. Very good job designing that. They're also going to do an interesting variant of along with regular 3D neural tracker training, where you're doing multiple object tracking with the balls on the screen. They're going to add a slightly sport-specific version, right? So try to improve on the critiques like myself and others have given about the generalized cognitive training having no information. So what they did, I'll show you this in a second. What they did for this is they had the multiple object tracking, and then they also had embedded in it a biological motion stimulus. So a biological motion is the little dots moving. It was a person passing the ball that they actually created these stimuli by recording a really real person passing the ball. You're gonna have to make a judgment about that. So you are making a sports specific judgment, picking up sports specific information. Um, the the sports specific information while you're also doing the multiple object tracking. Okay. Um, So in the present study, they're going to look for near transfer of training to this different cognitive tests, which you would expect if we're proving people's ability to focus their attention and selectively attend to certain objects, which is what multiple object tracking purports to do. We should get better on this other test. If the results of the previous study hold up, we should get better at on-field performance. Um, and also they're going to add a measure similar to what I did in my VR baseball batting paper, where they followed people for a couple of years after the study and see what competition level they reached. So if you recall, in my study, I showed that people which did my VR training, which is highly sports specific. Remember, not generalized. The people that did that condition, the variable training, more of them got drafted to MLB teams, play college ball, and so on. Okay, so they're trying to assess that as well, which again is a nice manipulation. Okay, so they had 62 players, male soccer players in very different age ranges. They're divided into control group and neural tracker group. Okay, they're only doing their regular training outside this, not any other cognitive training. They're all part of an academy, so the kind of very controlled environment. Okay. Um, the intervention period they're going to do regular multiple object tracking. This is 3D. You're wearing stereo glasses for 5 weeks, and then they're going to do the combined multiple object tracking with the biological motion. I'm going to show you this in a second for another 5 weeks, and that's all this the whole the neural tracker training. The control group didn't do any cognitive training at all and they just did regular soccer training. Okay. So in terms of the FAR transfer, right? They had these small-sided gameplay. They had 2 raters. They were watching people play soccer, and they had to score them based on their decisions, right? So they watch whether they made the right decision in a situation to a pass, dribble, shoot, tack. Again, that's problematic in and of itself because you're not allowing for individual differences or creativity. You have to conform to what the coach calls a good decision, but that's a common technique, and it's probably the best we have for now. So 1 is the right decision. So if there's a big gap opening in front of you, probably driving the ball to the net is a good decision. You get a 1. 0 if you passed in that situation. So that's decision-making scoring, and then the second scoring was on skill execution. If you pass the ball, did it actually get to the receiver? Um, the did it reach their teammate? You got 1 point for that, right? So that's kind of the base. So we're scoring their actual sports performance, transfer to sports performance again by 2 raters. This is, as I said, very common method for doing it. It has its own limitations, but it's good. It's much better than what's done in the original paper. So here's the 3D multiple. So here's on the top right. The regular NeuroTracker task is you have 8 balls that are in stereo, so they stand out in 3D. At the start of the trial, 4 of them are highlighted, and you have to keep track of the 4, and then point out which of your 4 at the end. So it's like the shell game, right? Where you put something under, right? You have to keep track of these objects. So that's the main part. When in the part where they add the biological motion, what they had was a stick figure created from a real person so it's a point light figure that was passing either to the left, right, or middle, right? And they had to decide which one they passed to. Which one they pass through. So this is I'll talk about this more in a little bit, but it has some sports specific information. Obviously, you need to pick up information from the person, the stick figures kinematics, their angles and joints to know which direction they're passing, right? So on each trial, person had to make 2 judgments. What were the 4 balls? Which were the 4 balls I was tracking? and which direction was the pass in them. Okay, so that's what they did. Okay, the near transfer cognitive test was called the SVAQ. Right, it's another computer-based test. Well, it's basically a test of sustained attention. So you have to sit there and you're watching a computer screen, and every time so you're just watching for a long period, and either you saw a number one or heard a number one, you pressed a button. When you saw a number two or heard a number two, you didn't. You inhibited a response. So it's a very simple test of a sustained attention. Okay. So that's the kind of the tests. So the actual procedure went like this, right? You did the lab test and on-field field test first is a pre-test. They split into two groups. The experimental group did the first regular neurotracker, then the neurotracker combined with the biological motion. The control group just did the regular practice. Then they did the same things in post-tests. What did they find? So first of all, very near transfer, right? So what did training on the NeuroTracker improve you on NeuroTracker, right? We're just talking about the basic tests, not the combined one, right? This sounds silly, but this is the main piece of evidence most sports training companies will give you for their product, right? If you train on the product, you'll get better at using that test, right? Which tells you nothing, right? This is you get trained on Angry Birds, you get better at playing Angry Birds. Does that make you a better soccer player? No. So what they found here is they found people had better tracking speed, were able to correctly identify the four objects at higher speeds following training on neurotracking, while there was no significant change in the control group, right? So even though this is good, we're ruling out any placebo or practice effects by having the control group. So there is very near transfer. How about near transfer to the other cognitive tests? So the one where you had to respond to ones and inhibit response to twos. What they found was essentially nothing, right? No evidence of no evidence of improvement on this test, which is kind of surprising, right? If there is this is just showing you the problem with this, right? If there is this general ability called selective attention, which is this like a general skill that you can train and then it will apply to any specific situation, then it should work. It should help you here, right? And it doesn't, right? Neither the NeuroTracker or the control group improved on this test after training. Finally, in the FAR transfer, in terms of both decision-making accuracy and skill execution accuracy, neither group showed any improvement, right? Neither group showed any improvement in performance. Any improvements in performance, they didn't show any. Both of them had the same result after pre and post test. So here's the proof, right? No evidence that training on NeuroTracker, even with that sport-specific biological motion, didn't help them at all, right? Didn't help them improve at all. They didn't show any evidence of improving at all on sports performance, right? So, again, so they basically didn't replicate any the findings, right? They didn't replicate the findings of the previous study. They didn't show any transfer training at all. Okay, so that's the results. The last result, when we look at FAR transfer, again, here is the results remember, they followed the people for 2 years after leaving the academy. What competition level did they reach? People that were in the control group, here's 6% of them reached the highest level, 30% the next highest, 23. Here's the control group. No significant differences, right? So there's no significant relationship between whether you did the neurotracking or the control group and what level of play you reached. So again, no FAR transfer, right? So again, this is a pretty convincing study. So I give the authors, so here's their conclusion. This follow-up study failed to replicate previous findings with dual task 3D motion tracking training, unable to produce near or FAR transfer on soccer performance. In addition, cognitive performance not related to early career success in the study. So no evidence of FAR transfer or even near transfer in this study at all. Right. So my thoughts, again, I give the authors big kudos for evaluating their own work and continuing to provide evidence like this. Right. I think it's finally time, that we retire the idea of generalized perceptual cognitive training. It doesn't fit in the ecological dynamics view at all, and there's no evidence of transfer of training. So I don't think it's an effective use of practice time, in my opinion. There's much better things you can do. I really like that in this task they added a sport-specific element to the neural tracker. So that soccer player created by the kinematics, right? Created by the point light figure. There's been some studies, for example, showing that improves in using that as a temporal occlusion experiment that actually can be used to improve, get some sort of transfer effects. The problem here, though, the experiment was still not, the task is still not designed to focus on that, right? The focus is still on, like, we're ramping up the speed of the tracking, the multiple object tracking. We're not changing the passing direction by very small amounts, right? So it's not designed to increase your sensitivity and educate your attention to information about passing. It's designed to improve your multiple object tracking, which does not transfer to sports, right? So I think if we had more precise information, where you had to make very small judgments, was the ball, and also action related judgments. Is the pass coming to me or not? Things like that. So I think there's ways you can prove this, but overall, I don't think there's much left to continue to pursue this line of research called generalized perceptual cognitive training. I don't think it's of much value. So that's it for today's episode. Thanks for joining me. Cheers for now, and keep them coupled.